are extra problems that you can use to prepare for the assessment on Monday. We're going to go through sections 3.1 through 3.4. A lot of these questions are coming from the Big Ideas Skills Trainer. So these look similar to it. It says find the domain and range. So domain, we're talking about x values. We want to list all of the x values that are graphed here. So if we took each point and looked at its x coordinate, x value in the coordinate, what would it consist of? Well, the domain, my x values, are going to go from -4 all the way to 2. So that would be -4 is less than or equal to x, which is less than or equal to 2. Why do I have these equal signs? Because this is a solution. This is a point, -4, comma, -1. So that is a solution. So we're going to include it, as is this point, which is 2, comma, 3. So we want values of x values between -4 and 2. That's on the x-axis. When we talk about the range, we talk about the y values. And what are the y values that consist of all these points? Now, y values go up and down. So my y value here is 3, and my y value here is -1. So I want values up and down from 3 to -1. So we would write this -1 is less than or equal to y, which is less than or equal to 3. Notice that each of these are numerical order. Smaller, bigger, smaller, bigger. That's why we do less than signs. Okay, again, my domain, I'm looking at my x values. This point is at -1 on the x all the way to 4. So we would have -1 and 4. And then when we look at the y value, we're looking up and down. So my smallest is -4, and my biggest y value is 2. Estimate the intercepts of the graph. Intercepts are where the graph, the line, aka the graph, crosses each of the axes. Each of the axi. So we're going to follow. Let's do this. Let's make it a little bit smaller. So we're going to take this and we're going to see where does this line, this graph, cross the x-axis right there. And where does it cross the y-axis? Where does this line cross the y-axis? Right there. This is the y-axis. This is the x-axis. So it crosses it right here. So the x-intercept is about, that's going to be -1/2. It's about -1/2. We want to look at the increments. Each box is worth 1. Always pay attention to the increments. And that's 1, 2, 3, -4. So the y-intercept on the y-axis, x-intercept on the x-axis. So notice this one. Well, let's do that. And let's go back to my other color. And let's do 2 of those, and we can grab them. So x-axis is going to be, oops. I want to separate those. Group, ungroup. Thank you. So those are my x-intercepts. This is my y-intercept. So my answers are going to be x-intercepts are about, what's that, -1, -2, and 1. And the y-intercept, -1, -2, -3, -4. So those are the intercepts for that. Approximate when the function is negative. So negative means when is it below? Negative is below. When is it below the x-axis? And when they say when the function is negative, what they're saying, negative outputs, meaning y values. When are my y values? These are my y values. When are they negative? They're negative here. If we took this point, that would have a negative y value. That would have a negative y value, negative y value. Once we hit the x-axis, my y value is 0, and then above my y value is 1, 2, etc. So that would be positive. So when is it negative? It's going to be negative below there, and you have to describe it by using inputs. Describe by using x values. So we're looking what x values produce negative y values. And that's going to start. So it's an intersection. It's a segment, excuse me. It's a segment. Segment is always going to have some value less than x less than some other value. My min value and my max value. So my minimum value is -1. So we'd say -1 less than x less than, and then my max value, which is 2. Notice on the x-axis, because I'm talking about the x variable. Increasing is talking about also my y values. Left to right. So moving left to right, when are my y values moving up? And we call that a positive slope. So when is there a positive slope? Nope, don't want that. So positive slope, it's moving up in a positive slope. It's increasing all the way to here. So all the way from infinity down there all the way to this point right here. So let's not do that. Let's to there. So it's a ray, not a segment. This is a ray. All rays start with x. Then we have an inequality sign, and we have our starting point. Starting point. So it starts here, which is -1.5. So we start with x. We do our starting point, -1.5. And now we need an inequality sign. And this inequality is going to be the side. So what side is my green? It's to the left. So we're going to do less than, because those values are less than -1.5. Those are the x values that are increasing. Okay, that's the answer right here. When is it decreasing? Okay, so decreasing is a negative slope. When is it going down left to right? So it's going down left to right. Here, it's going down left to right all the way to This point right here. And what is that point? So it's a ray. So I'm going to start with x. I'm going to do my starting point, which is 1 1/2. And now, do I want the values on the left or to the right? Well, my down values are to the left, so that is going to be less than. Describe the end behavior. In end behaviors, we talk about x going to positive infinity. That's going to the right. And then we talk about x going to negative infinity, and that's to the left. Because on the x-axis, to the right is positive, to the left is negative. And then it wants you to describe the y. What are the y's doing as we go to the right? And y talks about up and down. So as I move to the right, are these points going up or down? You notice they're going up. Up on the y-axis is positive infinity. Okay. And then if we look as we go to the left towards negative infinity on the x, what are my points doing? Are they going up or down? They're going down. So down is negative infinity. Now you don't have to write this. This is just what I'm going to look for. All right, so we always, is decreasing. Sorry, I thought that was end behavior question. It says, when is it decreasing? So when is the angle going down? It's going down, decreasing. And where does it start? It starts right there. So it's a ray. So I start with x. It's starting at where on the x-axis? At 0. And do I want the points to the left or to the right? I want the points on the right because that's the highlighted. That's the part that's going down. So to the right is greater than. Those numbers are greater than 0, 2, 4, etc. When is it positive? So if we're talking about positive, we're talking about above the graph. Above the graph. These are both rays. There are two different ones, so I'm going to have to write two equations. Write those starting points. That starts, so it's a ray. So we start with x. We look at the starting point. That's -2. Do I want the points to the left or to the right? Is the green on the left or the right? It's to the left, so it's less than. Let's look at this ray. Since it's a ray, we start with x. Where is it starting? At 1. And do I want the values on the right or to the left of it? I want them on the right. These are to the right of 1. So right is greater than. Is the domain function discrete or continuous? It's continuous because there's an infinite number of points in here. It is continuous because I can't pick all the specific points. There are an infinite number of them. This is discrete because we have specific points. Specific points. So each one is a point of its own. Which of the following equations represent linear functions? Oh, we didn't do this. we didn't actually do this on the pre-assessment, on the review, so this is good. So which one are linear functions? Linear functions have x to the first power in the numerator. In the numerator. Okay? So this is x to the first. So this is a linear function. This is in the denominator, so that's no. That's in the denominator, that's no. That's in the denominator, that's no. So only one that is a linear function is this one. Which of the following equations represent nonlinear? So nonlinear can be in the denominator. Every non x to the first. So this is x to the first. So that's no, that's not nonlinear. This is x to the first. That's nonlinear. This is x in the denominator. Yes, that's nonlinear. And this is x in the denominator and it's squared. So that is a nonlinear function. Nonlinear. So nonlinear, let's focus on what are we looking for. We're looking for nonlinear. So that's the first in the numerator. That's no. That's to the first. Whoops. That's to the first in the numerator. So that's no. That is linear. This is linear. This is linear. And this is the only nonlinear because it's x squared. So nonlinear is everything except for the ones that have x to the first. Which of the following graphs represent nonlinear? This is nonlinear because it's not a straight line, not a straight line, not a straight line. This is a straight line. This has a constant rate of change. This has a single slope. These slopes all change throughout. That changes and changes. So linear, let's make sure oh, yeah, nonlinear. Good. Now it wants to know which ones are linear. Well, this is nonlinear. It's not straight. That's not straight. That's not straight. And so the only straight line and that constant slope is what? 0. Rise 0, run 1. Rise 0, run 1. So this has a slope of 0. Which of the following graphs represent linear? So linear. That's not linear. That's not linear. That's not linear. This is linear. And what's the slope? The slope is -1. So slope equals -1. Down 1, right 1, down 1, right 1. Does the table represent a linear or nonlinear function? So when you're given a table, you check and see what am I increasing by? That's +6. That's +6. That's +6. This is plus, what's that, 18? This is plus 18. And that's plus 7, 14, 18. Plus 18, plus 18, plus 18. And now we take the difference of y's, the difference of y's over the difference of x's. So my y's is 18 over 6, which simplifies to 3. That's 18 over 6, which is 3. This is 18 over 6, which is 3. So the slope between these 2 points is 3. The slope between these 2 points is 3. And the slope, so that's a constant slope. So it is linear with a slope of 3. So let's do it again. Let's check. +2. That's +2. That's +2. This is +16. This is +24. And this is plus, what's that? Let's subtract properly. 32. 32, right? That's 24. That is 16. So let's do the slopes. 16 over 2, which simplifies to 8. 24 over 2, which simplifies to 12. And 32 over 2, which simplifies to 16. So these are not a constant. So not constant rate of slope. Not a constant slope. So it is non-linear because the slope changed from 8 to 12 to 16. We want to graph it. So remember these functions. These functions are in slope-intercept form. The coefficient of x, the number in front of x, is considered the slope. And then the constant being added is called the y-intercept. So in this example, In this example, the slope equals -2 and my y-intercept equals 2. We always plot the y-intercept first. You have to plot the y-intercept first. So the y-intercept is 2, so we make a point on the y-axis at 2. And now we're going to use our slope, which is -2. What is -2 as a fraction? -2 over 1. And -2 means down 2. And +1 means right 1. Because slope, remember, slope is rise over run. And when you rise, you go up, down. And when you run, you go right, left. So -2 is down, negative is down 2, positive is right. So we're going to go down 2, right 1, down 2, right 1. We're going to connect those dots. We're going to put arrows on that line to show that there are an infinite number of solutions. And then we're going to label each of the points. 0, 2. That is 1, 0, and this is 2, -2. You must label your points, and those coordinates must be next to the points so I know which one you're talking about. So my slope equals it equals -3/5, and my y-intercept equals -3. So we're going to go down to -3, make a dot. Now this negative sign can go in either one, not both, but it can go either up in the top or it can go on the bottom. Doesn't matter. So let's move this down a little bit. So if I keep it on the top, that is down 3 and then right 5. Or if we have 3 over -5, that is up 3, and that is left 5. So let's take that. We're going to let's do both ways. So we can go down 3, 1, 2, 3, and then down 3, and then right 5. So we've kind of run out. I didn't do a very good job. 1, 2, 3, 1, 2, 3, 4, 5. That point is right there. Or we can go up 3, 1, 2, 3, counting the x-axis. 1, 2, 3, 4, 5. So there is my line. Well, that's not bad. That wasn't too bad at all. Let's put some arrows. You must have arrows. I will minus points. Let's label the point. That is -5, 0. This is 0, -3. And this point is 5, -6. Now we have to calculate. That's -5. And remember, I went down one more because it was down 1, 2, 3. And that got me to -6. So that is graphing that. Let f of t be the outside temperature in degrees, t hours. So this is my output. F of t is my output, which is going to be temperature. And t hours is going to be my input. So explain the meaning of f of 4. So after 4 hours, this is the temp after 4 hours, and this is the temp after 18 hours. So the temp after 4 hours is going to be greater than the temperature after 18 hours. So let's the temperature at 4 hours after 4 a.m. Sorry. That's after 4 a.m. So that is going to be 8 a.m. is greater than the temperature at 18 hours. So 12 hours would be 4 p.m. And then we need another 6. So that's going to be 10 p.m. at 10 p.m. So the temperature at 8 a.m. is greater than the temperature at 10 p.m. That's an interesting place, right? 12 hours, and that's 6 more. Yeah, that's good. That's correct. Evaluate f of x equals negative 4x when x equals 7. This is my input. Notice my input, but this is going to represent my output. So I put it in for each of the places for x. I'm just substituting negative 7 in for x. Notice it went in there. So we get negative 4 times negative 7 minus 6, which is positive 28 minus 6, which is 22. So my output, when I input negative 7, my output's going to be 22. I'm inputting negative 9, so that goes into both places. Minus 1, that's negative 72 minus 1, which is negative 73. I'm inputting in for 6, so f of 6 equals 4 times 6 minus 5, which is 24 minus 5, which is 19. I'm inputting in for x, I'm inputting negative 3, so 6 times negative 3 plus 1 is negative 18 plus 1 is negative 17. All right, describe the characteristics, the domain. So my domain is talking about my x values. My domain, so what are all my x values? Well, this arrow says I'm going to forever that way. And this arrow says, even though it's going down, I'm also going to the right. So it is all real numbers. What is my range? My range is my y value. So I'm going to go up to positive infinity, down to negative. So that also, this is my y values. All real numbers. X-intercept. So where does it cross the x-axis? Where is it crossing the x-axis? X-axis, this is the x-axis. It's hitting it here, and it hits it here. Those are the two places on the x-axis. So on my x, that's negative 1 and 0. For my y-intercept, where is it crossing the y-axis? Well, it shares right there. So that is 0. So that point is not only an x-intercept, it's also a y-intercept. When is it positive? When is it above the x-axis? So it goes right to there. Then it goes below the x-axis. So it's a ray. So I'm going to, since it's a ray, I'm going to start with x. And then, do I want the points to the left or to, negative 1 is where it starts. And do I want the points to the left or to the right? I want them to the left, so left is less than. When we talk about negative, we actually got two little places here. This is a little tricky because right here it's 0, so it's not positive and it's not negative. So we have this little section, which is an intersection, which is a segment. So I want my min value. I want my max value. I'm going to put my variable and less than signs. The other one is array. And so array, you start with the variable. Where does it start? And then do I want the points to the right? Yes. So right is greater than. It's a little tricky. Okay. And now increasing. Where is this ever increasing? It's increasing kind of. This is another tricky one. That is really tricky. Well, let's clone this page. And Let's erase this just so we can see. It's very tricky because it's increasing right here. So it's increasing from right here to right here. That is really tricky. Boy, that's not an easy one to do. So from here to here, it's increasing. So from what? I'm going to say, because it's a segment, I'm going to say negative 1/2 to 0. It's increasing. So we put our variable and less than signs. And then when is it decreasing? Decreasing. This is decreasing all the way to this point where it increases. And this is decreasing. So we have two rays. So I'm going to say x is less than negative 1/2 and x is greater than, because it's to the right, greater than 0. So I want the points to the left of this and the points to the right of that. And my end behaviors, at least those are relatively, and let's do this. Oh, not that. See next page. See the next page. So end behaviors as x goes to positive infinity and as x goes to negative infinity. What's going on? To the right, this is my right arrow. My right arrow is going down. And this is my left arrow, because left is negative. That's going up. So that's going to be positive infinity. Good. Let's look at this one. So domain, all real numbers. And range, okay. Ooh, range is kind of hard too. Range is what's my highest y value? Right here, right? That's my highest y value. What is that value? I don't know, 1/4. So I need values at 1/4. We're going to do y is less than or equal to 1/4. Because at 1/4 and then all the values less than it. And we can include it because there's a point. The x-intercept, so let's look at x-intercepts. X-intercept is where it crosses the x-axis. Right here and here. So my x-intercepts are -2 and -1. My y-intercepts, where it crosses the y-axis, is right here. So that is going to be -2. When is it positive? It's positive only between here. So it's a segment. And my min and max, min is -2. Max is -1. And x is less than, ooh, I almost did equal to, no, because when it's equal, it's 0. And when is it negative? Negative on these two sections. So I'm going to have x is less than -2, and then x is greater than -1. So at -1, when is it increasing? It's increasing all the way up to, what's that, -1.5. So x is less than -1.5. And when is it decreasing? When x is greater than -1.5. End behaviors, as x goes to positive infinity, as x goes to negative infinity. My infinity signs are getting weak. So as I go to the right, I'm going down. As I'm going to the left, I'm also going down. Good? All right. That's it. Perfect. Love it. Good luck. Keep practicing. Use those skills, trainers.